All right, let's do some Mathity-Math. It says, for the resultant of each of the vector sums, find the magnitude and the direction. Again, we're going to assume an angle that is anti-clockwise from the direction of I. Okay, so this time it's in the form with our i's and our j's. Quick rule of thumb, you add the i's with the i's and the j's with the j's. That's just like terms, no big deal. So when we do this, let's just get to it. 7i plus negative 8i, well, that would just give us a negative 1i. You don't have to write the 1, but I like to, so there you go. And let's see here. 3i plus negative 5i, well, that's going to give us, 3j plus negative 5j, well, that's just going to give us a negative 2j. And we're cooking. I'm going to make that 1 look a little more 1-y. There you go. All right. So we got negative 1i minus 2j. Cool. And what we got to remember here is these i's are telling us which way we travel on the x-axis, and the j's are telling us which way we travel on the y-axis. So let me just draw a little model here, or a little sketch or diagram, and as always, do yourself a favor and take the time to draw a little diagram. It helps you see stuff. Okay, so I go back 1, sure. I go down 2, okie dokie. That puts me right about there. So there we go. And so now what we're looking at here is that is what the vector would look like. But they want me to find the magnitude and the direction. So let's tackle the magnitude first. Again, remember that this is making a little right triangle right here. The right triangle would look something like this. It goes down 1. That's a length of 1. And then it's going to go like this. And oh, excuse me, it's not going to go down. It's going to go down negative 2, down 2, and then back 1. There we go. That makes more sense. Okay, let me clarify that because I made a little bit of a mistake. This is our triangle right here, right? And this is the same one right here. Let me make that one pink too so you can see it. Okay, and you see here it went back 1 and it went down 2, but when we draw triangles, there's no such thing as a negative length, so we just write it as 1 and 2, and it's still a right triangle, and we can work with that. So we're just trying to find this hypotenuse of our triangle, and the way we find that hypotenuse is just by using the Pythagorean Theorem, which is just a squared plus b squared is c squared. There we go. So I'm going to come on down here so we have some more work, space to work. There we go. Okay, so just fill in. In this case, a is 1. So it's like saying 1 squared. Easy enough. Plus, and then we're going to have b squared, so that's like saying 2. Right here, that 2, that's 2 squared is c squared. Okay, luckily I can do some of this math in my head. So 1 squared is 1. Because 1 times 1 is 1, and 2 squared is 4, because 2 times 2 is 4. That is c squared. And that's going to give us 5 is c squared. Now I like showing my steps, make sure I don't make a silly mistake, which sometimes we all do. So now we're going to take the square root of both sides, and that's going to cancel out that squared exponent. And so let's see here. The square root of 5, I don't know this off the top of my head. The square root of 5 is, we'll say, 2.24. So we'll say c is 2.24. Okay, so right here, that magnitude is of a strength of 2.24, and that's also our hypotenuse, right? 2.24. Great, there is our magnitude. So now we got to find this direction, okay? And so it says here we're traveling anti-clockwise from the direction I. So for here, we're going to come all the way around to there, okay? So that's what we're trying to do. That's the angle we're trying to find. So if we look at this, again, we're going to be using, we have a right triangle, we'll just use right triangle trigonometry. So if we're using right triangle trigonometry, let me straighten that up, that makes me feel better. Okay, we're going to use SOHCAHTOA. SOHCAHTOA, remember, it tells us that sine, if we're going to use the sine of something, we use opposite over hypotenuse. Okay. We can use cosine. Okay, cosine gives us adjacent over hypotenuse. And then tangent, right, is opposite over adjacent. Now we have all three sides, so we could technically use any one of these we want, but I like to use the values that I didn't have to round. So what I want to do here, because I'm at this angle technically right here, what I want to do here is I want to use my opposite angle and I want to use my adjacent angle. So that's going to put me right here. Opposite and adjacent are right there. So we can find that angle. And this is going to lead us to a part that we should be able to do, but we do have to be a little careful. And so let's watch carefully here. So we have tangent of some angle we don't know is going to give us my opposite value, which is 2, and my adjacent value, which is 1. Or you can just call it 2. And because we're looking for the angle, we actually need to use the inverse tangent. So when we use the inverse tangent, we just hit second, tan. Let me clear this out and not distract you guys. We hit second and tan. Okay, that's my inverse tangent. And then I just hit 2 over 1. Voila. Again, making sure I'm in degrees mode, which I am. And there we go. We get 63.4 degrees. Now we have to be really careful here. So theta, it says, is 63.4 degrees. That's a little bit of a trap. And I want you guys to see why. See, if we went 63 degrees from here, we'd end up right about here. Right? Because you go up, 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 that's 90. Up, 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 that's 180. And so when we do this, we have to be aware of what quadrant we're in, or where we last referenced the x-axis, or where the I direction. So when I'm coming around here, I actually need to add 180 degrees to account for that travel. And that's actually going to be my answer for my angle. So I have my value right here. What I'm going to do is I'm just going to add 180. And so now I know that it's 243.4 degrees. And that makes more sense. So I'm going to say my theta is 243.4 degrees. And that makes sense. We're in the third quadrant. So it should be in between 180 and 270. Because we go 90, 180, 270, 360. So that makes sense. Now if you look at this paper, I got a lot of great calculations, a lot of great work. But I want my teacher to find my answer. So I'll go ahead and box these up. All right, there's my magnitude. There's my angle measure. And there you go. That's great work and good job. As always, please don't forget to subscribe if you want to be notified when I make more practice problems for you. And if you want to practice something more and you need more practice problems, just leave a comment below and I'll make sure to try and make one of those for you. All right, thanks. Bye.